Hello, I'm Steve Barsick Amstel with High Tech Design Safety. I'm going to run through a presentation I've created and shared with many clients and talk about how to get your product certified. More specifically, how to include those things that others have missed and design those in now so that you're able to have a product that gets certified more easily. So here's the top misses that we see on UL, SIMI S2, and CE marking. The biggest and first one is that it might not be designed to the standards that are required. So, for example, you're building a piece of equipment and maybe it has some moving parts in it and it's got maybe a laser in it. And of course, it has electrical section. So, first off, you need to include an electrical standard. So, let us help you pick that. It might be 60204, it might be 61010. It might also need to include NFPA 79. But you need to design your power inlet, power panel, and all of your power systems to one of those standards so that they're safe and conform to the standard when you go to certification. Now, subset of that is this one here is lack of overcurrent protection for system subassemblies. This one is a big one that people miss on, and it really causes a lot of extra time and equipment builds. For example, on this one, just recently we had a customer who didn't have overcurrent protection on the primary and secondary of a transformer. They had to go back in and add that, and that's a pretty big effort, especially when you're planning on shipping the equipment within that same month. And there's other very specific requirements for overcurrent protection at your power inlet, overcurrent protection for heaters and other devices, and also overcurrent protection for any convenience outlets. Those need to be GFCI protected as well. Generally, how we look at this is we try and find on the subassembly conformity information that says how it should be protected. Now, if we don't find that, then we have to use the load data and other calculations to determine that. So anyway, using the correct overcurrent protection is going to get your product to market much faster. The next one is incorrect wire types or sizes. Now, in the US, typically any power circuits, anything running at line voltage, needs to be 14 gauge wire. Now, you can use smaller gauges when you go to the CE standards. However, the reason that 14 gauge is required in North America, US, is that it's robust enough that it doesn't get damaged while you're building a custom piece of equipment. That's a simple thing to think about. And you can use smaller gauge wire, but then go back to the correct overcurrent protection. Any wire smaller than 14 gauge is going to require an overcurrent protective device rated for that smaller wire size. There you go. Next one is grounding and grounding missing from parts of the system. So last year, went on a field evaluation for a piece of equipment, and they didn't have the secondary neutral of a transformer grounded to the equipment. That's required. If there is a ground lug coming off of a transformer or another compressor or anything else, ground needs to be landed to that and go to the ground bus. The old days of stacking 15 different ring terminals on a single vertical screw coming through the equipment, that doesn't work either. And also note that grounding to a stainless steel screw isn't going to get you where you need to be. Stainless steel does have quite a bit of resistance, electrical resistance. It creates a lot of resistance, so you're not going to be able to pass the grounding resistance testing if you have it built that way. Each individual ground wire needs to run to a single stud. Often you'll see it done as a terminal block either one main terminal block where the main ground wire from the facilities comes into and grounds to the frame and grounds to everything else, or distributed ground blocks throughout your machine, depending on how big a machine it is. The next one, EMO interlocking. Okay, we see this a lot. You wouldn't believe me, but it's true. We'll go in and push an EMO button and it won't work. Or we'll open a door and while they were building the machine, they jump right out that door interlock just to make it easy. Got to fix those before it's inspected. And those are easy fixes. What's more difficult is interlocks that are not there or incorrect, or they're on the drawings, but they're not on the machine, so they're missing. All those interlocks, which are safety interlocks, need to be implemented using safety-rated devices so that they're correct, and they need to be implemented using the correct safety relay. And then the wiring between that needs to be correct as well. That's typically going to be low voltage wiring, so you don't want to have it run with any of your power wiring and all that stuff. So if you have questions, ask me on that. Sorry for all that background noise, but we're going to keep going. This is a big one. Lack of safety warning labels and nameplates or incorrect formats or information. Each different standard or standard group is going to have their own type of safety labeling required. We do have a template for nameplates. Let us send it to you. It's a very long template, and it's globally accepted. It has all the data for North America, for IEC-EX, in those cases that you're using that type of stuff. Europe, everything. It's got everything in it you need. It's a big nameplate, but it's what you need. And all those labels, nameplates, and data need to be reproduced in your manuals. And we'll talk about manuals coming up next. Lack of guarding. I see this all the time. It's crazy. But moving equipment with moving parts needs to be guarded, or it needs to be safety rated that it can't injure somebody. That guarding comes in several different types. You've got fixed guarding, you've got removable guarding, you've got guarding with hinges and interlocks, and the labeling and how they're fastened and everything is important. Note that nowadays, going forward, guards and enclosures must use captive screws, meaning you don't pull the screw out and set it down and then put it back in with, 2 of the 10 screws in place. Next one is seismic. Every piece of equipment should have seismic restraints. If you're going to be selling into the west coast of the U.S. or some parts of the east coast, there's a Ramapo fault in the New York area, or into Asia, Hawaii, anywhere where there is earthquakes, we have to do a full-on seismic restraint calculation. Now, I talked about this next one, safety devices not rated for use in the safety circuit. Tough one. If you're using a relay for a safety circuit, it needs to be a safety rated relay. Now, under some standards, we can get around that by using a highly reliable relay, derating it, protecting it, and everything else, but that's a whole nother bag of worms, and you might not get accepted anyway. So just use a safety rated device in your safety circuit. And we'll talk about safety PLCs and stuff like that later. And then ergonomics. Things are too heavy to lift. You can't hold a door open. The controls are too small, too large. They're not labeled. All of those things. These are the primary top misses when somebody's trying to get a listing, an S2, or a CE mark. Popped up to remind me what I'm doing. So each of these we go through in depth on these. Lack of current overcurrent protection we've talked about. That overcurrent protection must have 10,000 amps interrupt. You have to use a UL 489 breaker for North America for your main and branch circuits, and breakers should also have CE labeling on them. Use of subassemblies with no conformity information. If you're going to include a subassembly that uses line voltage to it, and you expect to get your equipment field labeled, it does absolutely need to be listed and marked. And that we can determine that it's actually listed. We recently did a project, the piece of equipment, it was a transformer, and it said NRTL listed on the transformer. As soon as I read that, I know it's not NRTL listed, because if it was, it would have the symbol of an NRTL there, and it would include the data required. And then also these subassemblies, we need the power and current requirements to withstand so that we can design the circuit and the overcurrent protection. Talked about incorrect wire types. We'll have to get in depth with this with yours, but know that particular wire types have to be used with your equipment. Also, the power cable that you plug into the wall to operate your equipment must be UL marked and listed for that use. Buying a unlisted cable, saw this just 2 months ago. The cable was unlisted because it was $1 cheaper per foot, and we weren't able to field label that equipment. We actually had to run down, and this is a different piece of equipment, run down to Home Depot, buy the right cable of the right size with the listing on it, take a picture of the reel with the listing on it, and reinstall it. And this is the appliance and AWM, appliance wiring, machine wiring. That should be limited to systems that are listed. Grounding is missing. We talked about that. You don't have to ground every single panel in your machine. That's overkill. Lots of people do it, and I'm okay with that. But really, we're looking for the enclosure covers and other parts that might become energized in a fault. And that main ground coming into your machine doesn't have to be, but it's best practice to have that main ground be the same size as all the power conductors. EMO interlocks, use safety rated parts. Those parts must be UL listed and CE marked, and we must be able to find that listing material. And all those circuits have to operate fail-safe. So let's work on all of those as we move forward. Lack of safety warning labels or incorrect formats like IEC, ANSI, or SEMI. Be sure that your labels have the proper data. You're going to need an icon, a signal word, a pictogram, and a message, and we can help you with that. Lack of guarding, I talked to that. Barriers must be permanent, fixed, and sturdy. And in some cases, we see people using polycarbonate, clear, see-through barriers. That's fine so long as they have enough strength and that they're built of a flame retardant material, and we need to be able to prove that. Lack of documentation in the manuals. One we were just talking about just before I started this video was the labels weren't recreated in the manuals, and the warnings for hazards were not recreated in the manuals next to each process, procedure, service procedure that created a hazard. So we need to be sure that you have that. So wrapping this up, those are the top nonconformances we see. And for a proven and tested path to conformance, contact us. We use what's called a conformity discovery process, which will get you past and through most of these things very quickly. Thanks so much. Have a great day.